Hi my dear students, all of you welcome to this class. Okay, yes, are you like to doing activities? Yes, so first I am going to do an activity. I take a tile plate and I take some ink. I take some ink. Yes. Then I take a chalk and place this chalk to this ink. What do you observe? Yes, what do you observe? Yes, ink blot on the chalk. That is, ink rises through the chalk. Ink rises through the chalk. Is it? Yes. Do you observe that? Yes. When I place this chalk to this ink, that time ink rises to the chalk. See it? Yes. When I dip some more time, ink rises here. Okay. Now ink rises. Is it? Yes, ink rises to this chalk. Yes. Next, like that, all of you take page 19. All of you take page 19. All of you take page 19. Yes, from this page we can see that there are some situations. First one is a piece of chalk is used to blot ink. A piece of chalk is used to blot ink. All of you look here. Yes, ink is raised through this chalk. Like that in a kerosene lamp. Do you see a kerosene lamp? Yes. How this kerosene lamp working? How this working? Kerosene rises through the wick. Kerosene rises through the wick. What is the reason for this? What is the reason for this situations? When a kerosene lamp, kerosene rises through the wick and the chalk ink rises. What is the reason for that? Do you know? Let's see. For that, all of you take page 90. You can see that there are two boiling tubes. There are two boiling tubes. One containing water and other containing mercury. One containing water and other containing mercury. Then dip a capillary tube into this. Dip a capillary tube into this. Okay. I just draw. There are two boiling tubes. One water, other what? Other mercury. When we put a capillary tube into this water and a capillary tube this mercury, what do you observe? What do you observe? Then this mercury yes, what do you observe this? Yes, is the water rises? Yes, water level rises through the capillary tube. Water level rises through the capillary tube. Is the mercury rises? No, mercury is not rises. Mercury is depressed. So, here depression process occur. Here rises. Here water rises in capillary tube. The rising of water is known as capillary rise. The rising of water against gravitational force is known as capillary rise. But what is capillary depression? What is capillary depression? The depression of liquid in a tube is capillary depression. In a depression of liquid, here mercury is depressed. So, the depression of liquid in a capillary tube is known as capillary depression. What are they? Capillary rise and capillary depression. So these are known as capillarity. These are known as capillarity. What is capillarity? The rise or depression of liquid in a narrow tube is known as capillarity. The rise or depression of liquid in a narrow tube is or a minute hole is known as capillarity. Got it? The rise or depression of liquid in a narrow tube or a minute hole is known as capillarity. Okay. Next, what is the causes of this capillarity? Let's see. For that, you can see that in your textbook page 20 there are some pictures. First one have what? Insects able to move along the surface of water. An insect able to move along the surface of water and a razor blade float on the surface of water. What are the reasons for that and how this insect can move along the surface of water? What is the reason of that? Because the surface of water stretched like a membrane. The surface of water is stretched like a membrane. That's why this insect can move afloat on the water. What is the reason of that? This liquid surface stretched like a membrane. What is the reason of liquid surface stretched like a membrane? What is the reason? This reason is surface tension. This reason is surface tension. New word, what? Surface tension. Due to the mutual attraction of the molecule on the surface of water, what is surface tension? Due to the mutual attraction of the molecule of the surface of water, the surface is stretched like a membrane. The surface is stretched like a. The force responsible for this is known as surface tension. So what is surface tension? Due to the mutual attraction of the molecule of the surface is stretched like a membrane. The force responsible for this is known as surface tension. Got it? Okay. Next, I take again this tile. Next, I take this honey. I take 2 drops of honey. We know that this 2 drops of honey is same molecule. We know that this 2 drops of honey is same molecule. Is it? Yes. This 2 drops of honey is same molecule. When I close to each other, that time this honey is together. Is what happened? Yes, this 2 drops of honey attracted each other. It like what? It is honey. It make a molecule that is honey. Okay. So what is this attraction is known as? The same molecules. The attraction between the same molecule is known as cohesive force. What is cohesive force? The attraction between the same molecule is known as cohesive force. What is next one? Cohesive force. What is cohesive force? Yes. The attraction between same molecules is known as cohesive force. Now here we can see that the same molecule of honey are attracted from honey. Okay. The attraction between same molecules is together is known as what? Cohesive force. Next we are going to study about adhesive force. What is adhesive force? Let's see. Yes. I take a pencil. It is the water in the glass. I dip this pencil into this water. What happened? Water is sticking to them. this water is sticking to this pencil. This water is sticking to this pencil. Then when I write chalk with this board, when I write chalk with this board, this chalk particle stick into this board. When this chalk particle stick into this board, is it? So here what is the reason of this attraction of different molecules? What is the reason of attraction of different molecules? Yes, the reason is adhesive force. So what is adhesive force? Adhesive force is the attraction of molecule. Attraction of different molecule is known as adhesive force. What? The attraction of different molecule is known as adhesive force. Okay. So what are adhesive force and what are cohesive force? Cohesive force means what? Cohesive force is the attraction between same molecule. Attraction between same molecule is cohesive force, and attraction between different molecule is known as adhesive force. Okay. Next in your page 21 we can see that figure 1.20. Yes, there is a picture. In a glass tube, imagine that it is a glass tube, water molecules, like that. Is it? Yes. What are the different type of forces in here? Which, now we studied about cohesive force and adhesive force. What are the different type of forces in this glass tube here? What are the different type of forces? Yes, here I have cohesive force and adhesive force. Adhesive force of water molecule and adhesive force between water molecule and the particle of which this glass. Okay, then cohesive force between the water molecules also have. There are two type of forces here. What are the adhesive forces and cohesive force? Then what about the force acting between the molecules on the water surface? Same molecules attraction, what is known as? Yes, cohesive force. So the answer is cohesive force. Then why did the molecule of water contact with the, you can see that the molecule contact with water molecule contact with the glass tube rises. Is it? Yes, here water rises slightly. What is the reason of that? What is the reason of that? Because the adhesive force between the water molecule and glass tube is greater than the cohesive force of water molecule. The adhesive force between the water molecule and glass tube is greater than the cohesive force of water molecule. That's why in a side water rise slightly. Okay. Next, what is the direction of resultant force of molecule? Direction downwards. Okay. What is the reason of this? What is the reason of this surface like an elastic membrane? Yes, we already said that. What is the reason of the molecules of surface like elastic membrane? What is the reason? Yes, surface tension. For surface tension, which force causes? Which force causes? Cohesive force, because cohesive force is the attraction of same molecules. Okay. So we can learn that what? We can learn that capillary rise and capillary depression. Yes, when occurs capillary rise and capillary depression. Capillary rise occurs when the adhesive force is greater than cohesive force. You can see that capillary rise occurs when adhesive force is greater than cohesive force, and capillary depression occurs when adhesive force less than cohesive force or cohesive force greater than adhesive force, that time capillarity depression occurs. Got it? All of you understand? Next, page 22, do another activity. Here we can see that arrange a capillary tube of different diameter. Take a capillary tube of different diameter. Okay. On a cardboard piece as shown figure, dip the capillary tube in water. This capillary tubes dip in water. What will happen? In which is the capillarity rise greater? There are different areas. Is it? Yes, capillarity of a different diameter. Which one have a capillarity rise greater? Smaller or which one? The tube is smaller or greater diameter? Of course, smaller diameter. Smaller diameter. In smaller diameter capillarity tube, which one capillary rise occur greater? Is it? Yes. Then in which is the capillarity rise lower? So we know that capillarity rise lower in larger diameter. Capillarity rise lower in larger diameter. Capillarity rise more in lower diameter, and capillarity rise larger in capillarity rise lower in larger diameter. Capillarity rise greater in smaller diameter. Is it? Next, how is the diameter of the tube related to capillarity rise? What is the reason of that? You know, what's the reason of capillarity rise greater in smaller diameter? What is the reason? Yes, we know that in smaller diameter, the weight of liquid can also be decreases. Weight of liquid can rise also decreases. So the weight of liquid in the tube is supported by, we know that, adhesive force. Here adhesive force between water molecule and this glass tube is greater than that of water molecule. That time we know that capillarity rise occurs. That's time, so that capillarity rise occur in which one? Smaller diameter capillarity tube. Capillarity rise occur in smaller diameter. Next, yes, I take again this plate. I put a drop of honey and I take this is color water. I take one drop of water and yes, this is kerosene. I take one drop of kerosene. Yes, then I tilt this slightly. You can see that which one floats speedily, which liquid is float slowly, which liquid flows slowly. Yes, you also try to do in your home. It is not too clear now. If we place kerosene, water and then which one, this honey, and tilt them slightly, we can see that this kerosene float fastly. This kerosene float fastly, then water floats. Then after this, we can see that this honey is slowly coming. Is it? Yes. This three liquid have a different speed. Three liquid have a different speed. Water flows faster than honey. We can see that water flows faster than honey, and this kerosene flows faster than water. Water flows faster than honey, and this kerosene flows greater than water. What's the reason of that? What is the reason of that? Do you know? What is the reason of that? There is a frictional force. We know that water flowing through a plane surface like this. Water flowing through a plane surface is by layers. Water or any liquid flows like layers. These layers. In time, there is a frictional force between the layers. There is a frictional force between the layers of liquid. There is a frictional force. There is a frictional force between the layers of liquid. This frictional force opposes the flow of liquid. This frictional force opposes the flow of liquid. There is a frictional force between the layers of liquid. This frictional force opposes the flow of liquid. This frictional force opposes the flow of liquid. This force is known as viscous force. This force is known as what? Viscous force. This force is known as viscous force. This force is known as viscous force. Next, viscosity. So, what is viscosity? Viscosity is the characteristic properties of a liquid to oppose the relative motion of the different layers. To oppose the relative motion, its different layers. Okay. So, viscous force and viscosity. Next, try to complete the table in your textbook, page 24. There are greater viscosity and lower viscosity. Greater viscosity and lower viscosity. Yes, from this activity we can see that honey is greater viscosity. Honey is greater viscosity. What are the other substances? Do you know what are the other substances have greater viscosity? Glycerin. Do you know glycerin? Yes, glycerin is also have greater viscosity. Then coal tar. Yes, coal tar also have greater viscosity substance. Coal tar. Coconut oil also greater viscosity. The lower viscosity, yes, from our activity we can understand that kerosene is very lower viscosity. So, kerosene, like that what? Yes, water, kerosene, water, petrol, diesel, etc. Petrol, diesel, etc. also have lower viscosity substances. So, greater viscosity substances and lower viscosity substances. What are they? Honey, glycerin, coal tar, coconut oil are greater viscosity substances, and kerosene, water, petrol, diesel, etc. are lower viscosity substances. Liquid have a greater viscosity is known as what? Greater viscosity is known as viscous liquids. Liquid have greater viscosity is known as viscous liquids. Liquid have lower viscosity is known as mobile liquids. Liquid have lower viscosity is known as mobile liquids, and greater viscosity liquids known as viscous liquid. Is it? Yes. Next, if we take, here we said that honey is greater viscosity. If we take honey in two glass tube, two boiling tube, one of the tube heated and other tube is normal, and take 2 drops of honey in both tubes, put like this in a glass plate or tile and tilt. In that time, what do you observe? What will happen? Yes, the heated honey flow faster. The heated honey flows faster. What's the reason of that? Yes, when temperature increases, viscous of liquid decreases. When temperature increases, viscous of liquid decreases, so that it can flow fastly than normal stage. Is it? Okay, got it all of you? Very good. Next, when a person here asks a question in your textbook, haven't you studied in your earlier classes that person who had an electric shock is to be massaged? Person who had an electric shock is to be massaged. Let's see what changes in produce of the body of that person. What changes produce the body of person? Yes, we know that the body of temperature of person, if he get an electric shock, falls suddenly. Body temperature of that person falls suddenly. It is the cause of hindrance of the blood. It is the causes of heart attack also. When we massage the body of that person, that time it is what happened? Yes, temperature it increases, hinders heart attack. When massage the body, warm of blood in normal level. Warm of blood comes to this normal level. That is the reason of for massaging. Okay. So when what is the reason of that? The temperature of the body of the person who had electric shock will fall suddenly. In that time it is the hindrance of water, the blood. In that time viscosity of blood also increases. Viscosity of blood increases. It is causing the water. It's causing the heart attack. When we massage that time, the temperature increases. Okay, temperature comes to normal level. We can help the person. That's the reason of that. Okay. Yes. Now we finished our first chapter. What have we learned to this chapter? This is a very big chapter about us. What have we learned to this chapter? First we learned that. Do you remember that? Yes, first we learned that buoyancy, buoyant force, Archimedes principle, the principle of flotation, then capillarity, then what? Relative density. Then now today we studied about what? Yes, surface tension, adhesive force, cohesive force, and last we studied about viscous force and viscosity. All of you must read this well and study this well. This is very important chapter for you. All of you study well. Okay? Yes. Thank you. Let's wind up today's class. Thank you. Assalamu alaikum.